Okay, students. Good morning. My name is Sankit. I'm your new science teacher. Today we are going to learn a new topic, which is named magnets. Okay, before that, hope you all doing well. And we already know that there's different kind of, different shapes of magnets. Some kind of magnets are in circular shape. Some kind of magnets are in rectangular shape. There are so many kinds of magnets, and there are basically we can or we will get magnets in two ways. That is natural magnet and artificial magnets. From naturally, from the Earth itself, we will get magnets. That is the very important thing. And artificial magnets, that is man-made magnets, are also there. Okay, and there are several properties for a magnet. Okay, that is why today we are going to discuss these kinds. What is a magnet and types of magnet. There are properties. What are the properties of magnets? What are the different shapes of magnets? Okay, that's all. So it is basically for this lecture is basically for class 8. Grade 8 students, and it is included in the class 8 textbook of Kerala syllabus pattern. And basically, it is also very important and essential for the CBSE and ICSE syllabus also. So if you have or if you need any fundamentals or basics about the magnets or magnetisms, you can carefully listen or watch these kind of videos. Okay. If you have any doubt, please feel free to ask me, or you can simply put a comment in the comment box and I will answer it. Okay. So let's begin, and I will share a PPT. Okay. Um, okay, I'm sharing. Just wait a minute. Mm, okay. Okay. Thinking that hope you guys see the PPT, and you can listen me, right? Are you guys listen this and see this video? See this PPT? Okay, this is basically for grade 8 science students, and the topic is that is we are going to discuss is magnetism. Okay, basically, my name is Sankit, and I'm currently pursuing B.Ed in Physical Science at Memorial Training College, Mavelikara in Kerala. Okay, then do you have seen this kind of magnet? What is the shape of the magnet? Yes, it is in U shape, right? So we can call it as U-shaped magnet, right? But it is a horseshoe magnet. Okay, we will assume that it is a U-shaped magnet, but it is wrong. It is a horseshoe magnet. If it is a U-shaped magnet, there will not be a bend. There will not be a bend towards these two arms of this magnet. Okay, here it is. Some bends are there that we will discuss in the next PPT. Yeah. First of all, do you have seen or do you know which is the fastest train in the world? Anyone? Do you know which is the fastest train? Yes, it is from the China. That is, we have learned that bullet trains. Bullet trains are very faster in the world, right? Okay, I have shown a video of this. Okay, this is bullet train. Okay, these trains are a kind faster than the train in our country. Okay, that is which is the world's fastest train. Okay, I have simply Google it, which is the fastest train in the world and which is the fastest train in India. Okay, the results are shown here. Okay, you can see this. Where which is the fastest train in India? All of you know that it is Vande Bharat Express, right? It is India's fastest train and with a top speed of 180 kilometer per hour, and which is also known as the Train 18. Okay, then which is the fastest train in the world? In the right part, you can see the Google gives us the it is a Shanghai Maglev. What is Shanghai Maglev? And what is the speed? 460 kilometer per hour, right? Okay, 460 kilometer per hour. It is in from China. Okay, so it is a list of the speed that is the top speed of the trains. First one is Shanghai Maglev, which have a speed of 460 kilometer per hour, and the second one is CR Harmony, which is also from China. This is the flag of China, which have the speed of 350 kilometer per hour, and third one also from China, which is the CR Fuxing for 350 kilometer per hour. Okay, this first train, Shanghai Maglev, which is a Maglev train. Maglev. You see this Maglev train. What do you mean by Maglev? Maglev. Hmm? What do you mean by maglev train? Maglev means magnetic levitation. We can divide these two words into, we can divide this one word into two. Okay, wait a minute. I will show you. Where's pen? Yeah, okay. This kind of word. Okay, we can divide into two. First one is magnetic. Magnetic. Magnetic levitation. What? Magnetic levitation. It is a kind of floating method using the magnets. Okay, levitation means floating. Okay, magnetic levitation. Magnetic levitation. Okay, magnetic levitation. I mean, this is not or, this is plus. This is plus. Magnetic plus levitation. Magnetic levitation, which is the short form of this magnetic levitation is maglev. Okay, Shanghai maglev. Okay, Shanghai maglev is an example of magnetic levitation. So it is the world's fastest train. So which is using basically using a magnet or electromagnets. Okay, electromagnets means the magnet is connected with the electricity. Okay, which is known as the electromagnets. Okay, electromagnets are used for operating this kind of train. Okay, hope you understood. And we can move to the next slide. Okay, this is a video of Shanghai Maglev train. Okay, you see this SMT. SMT means, what do you mean by SMT? SMT means Shanghai Maglev train. Okay, this is the world's fastest train. Okay, which is entirely different from the shape of our train, right? From Vande Bharat or from any other express train or any other super fast train in our country, which is entirely different from our shape or the rail or anything. Okay, which is comes towards a station. Okay, in China. Okay, you see this here? You see this? There will be no rail. Okay, there will be no wheel for this train. Okay, there will be no wheels or rails for this train. Okay, which is very peculiar. I mean, which is very unique from our trains. Okay, you know that in this train, these trains are working, which is based on the magnets. Okay, in the upper side of the, I mean, in the bottom part of this train. Okay, in the bottom part of the train, there are so many magnets are there. Okay, here you can see there are so many magnets are there. Okay, similarly in this kind of rail, right? Okay, which is entirely different from our rail, and in the bottom part also. Okay, in the bottom part of the train and in the upper part of the rail also there are so many kind of magnets are there. Okay. If there is north and a north pole coming, north and north pole coming together, the poles will repel. The poles will repel. Okay. If you assume this as the rail and this as the train. Okay. This rail now it is north pole or south pole. If it is assume that it is north pole and the train bottom part also north pole. What happens? North and north become repel. North and north pole become repel and it cannot attract together. It will repel. It will repel and basically it will float. Okay, if it is south pole and the bottom part of the train will also be a south pole, it will repel. It cannot be get attracted, it will repel. Okay, if the train is lowering their speed, if the train is nearing to the or is coming near to any station, what happens? The speed will lowering. Okay, the train need to lowering their speed. So what happens? It will become north and the bottom part of the train will become south so that both get attracted and due to this attraction the speed will become lowering. Okay, if this is the working principle of this maglev train. Hope you understood. Okay, let's move to the next slide. That's what do you mean by magnet? Basically, magnet. What do you mean by magnet? Magnets is a material object that produces magnetic field. Okay, so magnet is a material object. Okay, it is basically a material or object that produces magnetic field. Any kind of material that produces magnetic field, which is known as the magnets. Okay, then where can we find these kind of magnets? We know that magnets are our childhood friends, right? From our toys or from any motors or anything we can find magnets. Okay, so we already played with a lot of magnets from our childhood, and we already know what are the different the shapes of the magnets and all. So where can we find these kind of magnets? First one is loudspeaker. Okay, from the loudspeaker we can find these kind of magnets. From the microphone we can find magnets. From the washing machines, from the video players, from the computer floppy drives, from the electric bells in your schools. Okay, we also can find these kind of magnets, right? Okay, next, what is the type of basically two type of magnets? Where can we find magnets? First one is from the natural source. First one is from the natural source, which is also known as natural magnets. from the second one is artificial magnets. Artificial magnets are man-made magnets, right? Natural magnets are which is exclusively or we can directly find from the nature. Okay, that is the basic example is that you just take a magnet, a bar magnet or anything, a magnet, and put in the soil in front of a house. Okay, put in the soil, simply put in the soil. Okay, what happens if you take the magnet back? Just some kind of small the sands or some kind of small soil pieces or anything that is pasted in these kind of magnets, right? Which is the natural magnet, which can be obtained from the earth. Okay, so natural magnets are found naturally from the earth, right? That is magnets obtained directly from the nature, which is known as natural magnet. Okay, it has regular or irregular shape. We know that natural things are irregular shape. This rock is a magnet, and rock is irregular in shape, right? Okay, we need to shape it into our own needs. Okay, for example, lodestone. Lodestone is a natural magnet. Then what do you mean by artificial magnets? Artificial magnets are man-made magnets. Okay, that is created by humans through various manufacturing process or through industrial process. We can find or we can create those magnets in industry or factories, which is known as the artificial magnets, which are made by humans. Right, it can be formed in different regular shapes or different regular shapes. We can find or we can form different magnets in different shapes. Example, neodymium magnets. Ring-shaped magnet is one of the ring-shaped magnet is neodymium magnets. Okay, we can say you can see this. Okay, you can see here. This is neodymium magnet. Okay, then next we can find it as different what are the different shapes of magnets. Okay, first one is U-shaped magnets. You know that this is a U-shaped magnet. If these two arms of the magnet are close to each other, that is this thing. Okay, these two are close to each other, which can be named as horseshoe magnet. Horseshoe magnet. Okay, and this is perfectly U-shaped, so it is known as U-shaped magnet. This is not perfectly U, but two arms are close to each other, so it is a horseshoe magnet. And this is like a ring shape, and so this is ring shaped magnet. Okay, this is a circular magnet, this is a bar magnet, and in addition to that there is a disc magnet is here. Okay, this is disc magnet. Okay, this is disc magnet, and this is spherical magnet. Okay, and this is cylindrical magnet. So there are different shapes of magnets are available in our market. Okay, which is basically based upon the different needs and applications. Okay, so we can find different shapes of magnets. Okay, you just see that in the ring-shaped magnet or in the bar magnet or horseshoe magnet or U-shaped any kind of magnet, there are two types of S and N are present in here. Okay, S and N are present in here. What do you mean by S and N? Anyone? What do you mean by S and N? Yes, in the same magnets, we can find S and N. What do you mean by S and N? Okay, this S is south pole, south. These represent two poles of the magnet. First one is south and the next one is north. What? Next one is north. Okay, that is basically representing in us S and N. In every kind of magnet, we can see that. Okay, if it is S or if it is N, this will be S. If it is N, the bottom part will be S. Okay, if it is S or if it is N, if it is S, then it is S. Okay. So we can find basically two kind of poles in every kind of magnets, okay, which represents south and north pole. Okay, if we bring two magnets of the same kind, I mean south and same pole, the south and the south pole will what happen? They will repel. They will repel. They don't get attracted. They will repel. If it is north pole and this is south pole, what happens? It will attracts. It will attracts. Okay, if it is a south pole and it is a north pole, it will attract. If it is a south pole and south pole, it will repel. If it is a north and north pole, it will repel. Okay, hope you understood. Let's move to the next slide. Okay, okay. You can see here, every magnet have two ends, right? Every magnet have two ends, north end and south end. Okay, every magnet has two ends. Okay, those ends are called poles. Those ends are called poles. Okay, those ends are called poles. First pole is north pole and second pole is south pole. Okay, do you have seen that this is a bar magnet? Okay, bar magnet. This is a bar magnet. Bar magnet is rectangular shape. Okay, rectangular shaped magnets are called bar magnets. The opposite poles, what happens? This is opposite pole, south and north, opposite poles. Opposite pole means unlike poles. Okay, that is south and north poles becomes attract, right? These becomes attract. If it is same pole, what happens? That is north and north pole bring together. What happens? It will repel. Okay, it will repel. If it is south and south pole, it will repel back. Okay, this south pole become move towards this, and this south pole become move towards this. Okay, if it is north pole, the north pole become move towards this way, and the north pole become move towards this way. Okay, if it is south and if it is north and south, or south and north, it will attract together. Okay, hope you understood. Okay, if we have a bar magnet, and if we attract, or if we put a nail towards the north pole of the bar magnet, what happens? The nail will attract, because iron is attracted by magnet. Okay, iron is a magnetic property, or iron is attracted by magnets. If it is a nail is put towards, or bring towards the north pole, what happens? This part become south pole, and this part become north pole. Okay, hope you understood. The south, that is why north and south will attract each other. North and south will attract each other. If you bring another nail on the bottom part of this nail, what happens? It already become north pole, and the south pole become the upper part of this nail, the second nail. Okay, then this north and south will attract. Similarly, if you bring another nail towards the bottom part of this nail, what happens? I mean, in the second nail, what happens? The north, it already become a north pole, and this upper part of the third nail will attract, and this become a north-south pole, and it will attract each other. Okay, here we can clearly found that if you bring a north and a south pole together, it will attract. And if you bring a north and a north pole together, what happens? It will repel, because these two are like poles. Like means similar poles. Okay, like means similar poles. If you bring north and south, it will become attract, because they are unlike poles, which means non-similar poles. Okay, if you attract, or if you bring a north pole and north pole together, what happens? It will repel. Okay, because they are like or similar poles. Okay, let's move to the next slide. Okay, you all guys already know that magnetic compass. Okay, hope you guys seen this and used this. What is the use of this magnetic compass? Anyone? What is the use? Basically, who use this? So, what is the use of these kind of things? Okay, do you think about this? Hmm? Okay, this is basically we know that in the magnetic compass it is represented as this is south, this is west, this is north, and this is east, right? This is southeast pole, this is southwest pole, this is northwest, and this is northeast. So basically it shows direction, right? And this is north pole, and this is south pole. This needle is act as a magnet. Not is act as a magnet. This needle is a magnetic needle. Okay, this magnetic needle gives us the what direction, actual direction. Okay, so which is your magnetic compass is used for what? Which is used to find what? Used to find the direction, right? So magnetic compass is used to find the direction. Okay, do you understood? So what is the use of the magnetic field? It will be a 1 mark or 2 mark question in your question paper. Okay, so it is used to find the direction. Okay, or this answer is also correct. It is used for the navigation. Okay, and also we can use this kind of magnetic compass for finding the magnetic field lines. Magnetic field lines. Magnetic field. What do you mean by magnetic field lines? These are imaginary lines around the magnet. Okay, so which can be also useful for magnetic field lines. Okay, then you can do a example in your home. I mean, experiment in your home yourself. Ask, take a bar magnet. This is a bar magnet. This is North Pole, and this is South Pole. Let us assume, and it is tied by, it is knotted by a thread, a thin thread, and hang it. What happens? It will automatically align to the our geographical, I mean, Earth's, this is Earth, this is North Pole and this is South Pole. And if you will hang this kind of, or if you do this kind of experiment in your home, it will automatically align to the South Pole and the North Pole of the Earth. So that we can find which is the North and South direction and the East and West direction of the Earth. Okay, I hope you guys enjoyed the session, and Okay, next, this is the pictorial representation of the geometrical, geometrical pole of the Earth, and this is the magnetic poles. Okay, you know that this is the magnetic field lines. I have already shown you. This is the magnetic field lines. These magnetic field lines are all starting from now North Pole and end in the South Pole. Okay, you guys remember this in north, the magnetic field lines are starting from North Pole and ending in the South Pole. Always just remember that. And next, we will discuss the okay. We are going to discuss the properties of a magnet. Okay, properties of magnet. What are the properties of magnet? Do you know? Which are the properties of magnet that you can already know? Which one? First one is attractive property. You know that south and north pole. South and north pole attracts, or north and south pole become attract. So it have an attractive property. There is such as a magnet attracts magnetic materials like iron, cobalt, and nickel. Do you know that every metals get is it every metals get attracted by magnets? Such as aluminum or copper or gold or silver or anything get attracted by magnets? No, never, never. Okay, so some kind of materials which are magnetic in nature, such as iron, cobalt, nickel. Iron, cobalt, nickel, or their alloys, they will always, or they only get attracted by magnets. Okay, not the aluminum not get attracted by magnets. Aluminum not get attracted. Aluminum is a metal, so aluminum is not get attracted by magnets. Similarly, sodium is not attracted by magnets because sodium is also metal. Sodium is not attracted by magnets. Similarly, gold is not attracted by magnets. Gold is not attracted by magnets. Similarly, silver is not attracted by magnets. Okay, and such many more metals. They are not attracted by magnets. But iron, if there is an iron or iron nail or cobalt metal or any nickel metal or their alloys means their mixtures. Okay, some kind of iron plus some kind of nickel or some kind of iron plus some kind of cobalt or these three combinations, any metals can be made. Those are known as alloys, and those alloys are get attracted by what? Attracted by magnets. And the next one is repulsive property. That is I already discussed. That is north and north pole get repels, and the south and south pole gets repelled. So repulsive property is also a one of the property of the magnet. Next one, directive property. That is direction, which shows the direction. That is why we are manufacturing those kind of magnetic compasses and which is used for navigation and to find the direction. So directive property is also a property of the magnet. Next one is two-pole property. Every magnet have north and south pole. That is an example for this. If you have a bar magnet means rectangular shaped magnet. Okay. If you have a bar magnet, this is the north pole and this is the south pole. Okay. If you are breaking this into two pieces, if you are breaking into two pieces, what happens? The north pole become separated out like this, and south pole become separated out into this. Okay, if you break this kind of things. Okay, if you break this kind these magnets, it will be separated out into two pieces. Okay, then automatically what happens if it is north magnet and this part becomes south pole and this part become north pole. Okay, you guys don't think that these all things will become south pole and these all things become north pole. Don't think like that. Automatically it become this pole become south and this pole become north. Okay, if it is north, this becomes south, and if it is south, this becomes north. Automatically, it will happen. Okay, so every magnet have two poles. Every magnet have two poles. One is south, and another one is south. Okay, one is north, and another one is south. Okay, so there are two poles are there. Okay, next one. Wait a minute. Okay, 1 minute. Okay. Next, we are going to discuss the topic properties of the magnet. That is already I have discussed. Already I have discussed that the first next one is properties of magnet. Okay, magnet attracts objects made of iron, nickel, and cobalt. Next, magnet have two poles, that is north pole and south pole. and poles always 16 pairs. Okay, poles always 16 pairs. If it is north, this is south. If it is broken down into two pieces, automatically this becomes south and this becomes north. Okay, this is already I discussed. And opposite poles of the magnet attract each other. That is, we discussed that is north and south is there if it is attracted to each other. Okay, so the next property is like pole of the two magnets repel. Do you see it? Like poles, that is north and north is there, or south and south is there. These two poles become repel. Okay, if a magnet is suspended freely by a thread, it aligns itself in the north-south direction. Okay, that is already we have discussed. Okay, next we are going to take some multiple choice questions. Okay, from this we can see that which image correctly shows a bar magnet. Which one is bar magnet? If you see in the bar magnets are rectangular magnets, so it is a horseshoe magnet. It is U-shaped and bent, and there will be a arms bent. So it's a horseshoe magnet. So it is not correct. So here, these three are rectangular magnets. So any one of these will be the answer. But here we can see for a magnet, there will be two poles. Here it is to a north and north is there. So it will not be answer. Here it is south and south, it won't be answer. So here it is so north and south, so it is the answer. Okay. So next question is move the sticker to the correct answer. Okay, move the sticker to the correct answer. Okay, which of the objects below does a magnet attract? Which one is attracted? Is the gold is attracted? No. We already seen that nickel, cobalt, and iron, it will attract it. Okay, plastic. Plastic is attracted? No. No, no, it is a common sense. Plastic is not attracted. Yarn. Yarn means it is a kind of thread. Okay, it is not get attracted. So iron screw is get attracted. Okay, so next one is when two magnets are placed with opposite poles facing each other, they will. What happen? If it is north and if it is south, what happen? It will break or attract or transform or repel. What happens? North and south, they are unlike poles, so they will get attract. Yes, very good. Next, move the sticker to the okay. Next, look at the magnets below. What do you think will happen when they get released? Okay, if you get released this, what happens? This is south and this is south pole. So this is like poles, and it will get repel each other. They move apart, right? They will move apart. So first option is they will attract. No, no, no. This is not. They will repel, and yes, this is correct. Third option is they will attract. No, no, nothing will happen. No, no. So the second option is correct. Okay. Next one is look at the magnets below. What do you think will happen when they are released? When we get released, look at it is directly towards the south pole. Okay, it is directly towards the south pole, so south and north pole. Here also north is directly towards the south pole. What happens then? What happens then? North and south. So they are unlike poles and they get attract. They get attract. What happens south and north though? So they get attract, right? So they will attract and stick to each other. Yes, this is correct. They will repel. No, no, no. This is not answer. They will attract and then repel each other. No, no, no. And they will attract and stick to each other. The first option is correct. Nothing will happen. No. Next question. Yeah, this is the answer key. Okay. Hope you guys enjoyed the session. If you have any doubts or anything else, just comment to the video. Okay, just comment to the video and hope you guys enjoyed the session. See you later. Okay, bye.